we want to write tangent in terms of cosine. Tangent in terms of cosine. So remember what that means is that the left-hand side, all we're going to see is tangent of t. And on the right-hand side, there's going to be some algebra, but the only trig function that you see over there on the right-hand side is going to be cosine. That's the only thing that they're allowing here. Okay? This quadrant 3 thing, I think maybe it warrants discussion once we actually get the algebra process completed. Okay? So, in doing this problem, we need to look and use these relationships here. And actually, let me go to these notes because nothing's filled in on these yet. Okay, so if we're doing this problem, we want to make some substitutions. These substitutions usually, these identities, which are reciprocal identities, are usually not the ones that you're going to use initially. Those often are your second step, third step, fourth step substitutions, okay? These here in this section are the ones that you're usually going to start with. When we start doing this stuff in chapter 7, and we call it proving identities or verifying identities, they actually start us off with what we need. And that makes things a little bit easier. Because some people see this and say, okay, well, I don't even know where to start. What you're going to do is you're going to say, okay, I'm starting with the tangent. And I need to get it so it's written in cosine. So I need to develop I need to look at these up here and say, okay, which ones involve tangent and which ones involve cosine at the same time. Okay? And none of them use the word tangent and the word cosine at the same time, correct? Yes. But does any of them use their reciprocals? Does this one here uses tangent and its reciprocal, right? Yes. Okay. So that's the one that I'm going to look at and start with. So I'm going to write tangent squared t plus 1 is equal to secant squared t. That's what I'm going to use to conduct this process. Okay. The next step and the next two steps are actually independent of one another, meaning you can flip-flop their order. Okay? One step you have to conduct is to isolate tangent. The other step is that you have to substitute secant squared with cosine squared. 1 over cosine squared. Does that kind of make sense? But those can be done in any order. Okay? I'm going to isolate tangent first. So take tangent squared t is equal to secant squared t minus 1. And if I'm isolating tangent, I now have to take the square root, right? So I have the tangent of t. When I introduce a square root, it's plus or minus. And then it'll be secant squared t minus 1 under the radical. Which now, if we look at that, we have currently, if we think about what we've done, we have solved for tangent in terms of what? In terms of secant, okay? We're close. Now all we have to do is make the substitution that tangent of t is equal to plus or minus 1 over cosine squared t, bless you, minus 1. Okay? And that is a fine answer. Okay? But we have to do a little bit of work yet to really decide which one of these pluses or minuses we choose. It says tangent in terms of t being in the third quadrant, right? Tangent in the third quadrant is what kind of number? All the students take calculus. So third quadrant is t, so it's positive. Tangent is positive, third quadrant. So some people are going to say, I'm going to write this, and they're going to circle the positive one, type that in, and it's going to give you an error. It's going to tell you you're wrong. Okay? If you were to evaluate that right now, you're like I said, you're going to see some issues with your sign. So this is what I'm going to do. I'm actually going to condense this radicand. I'm going to make it one fraction. I'm going to copy this stuff down here and give myself a little bit more room. So tangent t is equal to plus or minus 1 over cosine squared t minus 1. Okay. So we're going to condense this radicand. And that is the one issue that you come across a lot through this whole course, is that they want you to simplify. And this is throughout all of algebra. They want you to simplify, but there's never, if you go back to working with fractions in like the 5th and 6th grade, there's never a degree of simplification that is expressed. Meaning, if I start with, 6 over 12, well, I can rewrite that as 3 over 6. I simplified it, right? But is that fully simplified?
No.
No, okay? That is the idea that we want to think about in our mind. This is an equivalent solution, but it can be simplified further. So we're going to do that. If I'm going to subtract these two things in the radicand, what do I need? Common denominator. So I'm going to rewrite this as 1 over cosine squared t minus cosine squared t over cosine squared t. And now I can rewrite that as plus or minus 1 minus cosine squared t over cosine squared t. And that denominator is the whole reason why I tried to merge that fraction. Because we know that the radical or a square root of a fraction is equivalent to a fraction of square roots, right? I can go ahead and break this up into 1 minus cosine squared t over the square root of cosine squared t, right? That makes sense? But what is the square root of cosine squared t? Cosine t. That was the whole purpose of breaking this apart. Okay, or I guess merging the fraction, and then I can break apart the radical. Okay, so now what we have here, this is the final solution that we're going to type in. And now it's important to see earlier, if I wouldn't have simplified this, I would have made the argument that I'm going to put the positive square root in, right? I'm going to choose the positive version. Just tangent in third quadrant equals positive. Here, okay, when I plug in t, okay, this radicand, I'm squaring the cosine of t, so it's going to be a number between 0 and 1 ultimately, and then 1 minus that will give me a real number underneath my radical. So I got plus or minus a real number as a numerator. Does that make sense? Okay. The bottom though, when I put in cosine of t, and t had to be in what quadrant? Third quadrant. Cosine in the third quadrant, what kind of number is that? Negative. Okay. So right now, this thing here is contributing a negative to the overall process. But I want tangent to be what in the third quadrant? Positive. So right now, I've got to choose. Do I use a positive divided by a negative? This is going to be negative right there. Do I take a positive divided by a negative, or do I take a negative divided by a negative?
Negative.
Negative divided by a negative. So my answer, I have to choose that sign there. That kind of makes sense? And I think that's kind of, initially, the first couple times you do, that's kind of screwy, but you have to realize that is a symbol for some other number, right? And we don't know, when I say I've got essentially a variable expression, I don't know if that variable expression is going to be positive or negative. But once they tell me where t is going to be, now I know that variable expression is going to indeed be negative. So then how do I make a quotient a positive number. If the denominator is negative, I got to divide it. My numerator is got to be negative. We can check these, and I think this is a good thing to do. I'm going to go to Desmos. I like to, so there's a lot of different Desmos versions of the calculators. We've got, I think I've shown you this one before. I predominantly use that one in my algebra class, but this one is the one that you're going to want to use because it incorporates secant, cosecant, cotangent. So you just type in secant and it'll work. But what we just came up with was tangent of t. That was the left-hand side, right? The right-hand side was the square root of 1 minus cosine squared t divided by cosine of t. Okay? Now t needs to be in the third quadrant, right? So I'm going to put this in. You could leave it in radians and write your decimals for your quadrants. I'm going to put it in degrees because then it's easy to talk about the third quadrant as 180 to 270. If I left it in radians, I have to write that as pi or 3.14 and this 3 pi over 2 or 4.71. Okay? But now if I do that and I hit play and stop, what do we recognize about those two numbers that I'm generating? One's negative, one's positive. So that would have been if I would have taken the positive version of that numerator square root, right? So to fix that, we negate the top. And that maybe validates, now as I play that through, no matter where I evaluate t, at those angle measures between 180 and 270, these two things are always equivalent. Does that kind of make sense? Let's see if I would type in square root of, what was it, 1 minus cosine, no, it was 1 over cosine squared t minus 1. Okay, there, and that's the idea. If it was plus or minus, if I left it this way, obviously you would see to get it to be equal to tangent t, you would have had to kept the positive one, right? Okay. So the reason I show you, so you could have typed, and this is just WebAssign, and remember WebAssign's not the end all be all. You could have typed that in right there. Okay, keeping the positive version. But most of the things that we do are going to want us to go this far. Okay. When you type it into WebAssign, so this is the solution that I get. So if I would type something in wrong and get the feedback and it gives me the answer, this would be the answer. Does that make sense? Where if I would have left it this way, I might not think that I'm anywhere close to having the right answer. But it could just have been the plus or minus that I forgot, but I've got it in a different format. So it's always beneficial when you've got fractions to merge them, make them one fraction. 25. So sine in terms of secant. Bless you. And we are in the fourth quadrant, right? Sine in fourth quadrant, what kind of number? Positive or negative? Sine. Sine is negative. So when we're done, whatever we end up with, we should make sure that it is a negative result. So now I'm going to look over my identities and what we want. Sine in terms of secant. Do any of these use sine and secant together? So that kind of stinks, right? So if there's none that use the two identities that they express directly, I want to see, does any one of those up there use one of those identities and the other one's reciprocal? The first one. Because sine is the first one that they gave me, right?
Yeah.
Is that the reciprocal of secant? Okay, so that's the one we're going to start with. So sine squared t plus cosine squared t is equal to 1. Okay. Again, you're going to have to, the process is going to isolate sine and then substitute cosine squared t with 1 over secant squared t. Okay? Those are independent. Those two steps can be done in any order. Which one you want to do first?
2.
Okay, so I'm going to have sine squared t. So cosine is 1 over secant. Okay? Now I'll solve for sine. So what am I going to do if I'm going to solve for sine? Okay, so we're going to have 1 minus 1 over secant squared t. Okay. At this stage, there's I think 2 steps that you can conduct. You can go square root. I don't know why I put 2 there. Or you can, I'll just say merge your fractions. Which one do we do first? Okay. So if I'm going to merge fractions, what do I need? Common denominator. So common denominator is going to be secant squared, right? So it's going to be secant squared over secant squared. That's my 1. Minus 1 over secant squared, right? Okay, that's what sine squared is equal to. So now I can go ahead and rewrite that as, so sine of t, or sine squared of t is equal to secant squared t minus 1 over secant squared t, right? Now what? Square root. Square root is going to give me that, right? And just give me sine of t. Well, square rooting that, is that numerator that? I should have a plus or minus here. And my secant squared, so the denominator is going to be this, right? Secant squared t underneath. But what's going to happen with that square root in the power of 2? They cancel. Okay. So now the way I've gotten this written, remember we wanted to be sine. So this is my answer. I just got to choose the plus or minus. Sine in Q4 is negative, right? So I want to figure out, how do I get that quotient to be negative? Okay. Well, this secant doesn't have a plus or minus in front of it. So I got to figure out, if I'm in the 4th quadrant, if t is over here in the 4th quadrant, is the secant positive or negative in the 4th quadrant? It's positive, okay? And usually I ask the question, is the cosine, instead of asking the secant, because I don't memorize the secant, I just know the cosine is positive in the 4th, right? And if the cosine is positive, so is its reciprocal. So that's going to contribute a positive number. So if that's positive, which one of these do we have to choose up top to make the sign negative? We have to choose the negative. So that's what we're looking for as our final value there, final expression that we're going to type in. Okay. One question for you real quick, because I get a lot of this. And it usually happens on tests and quizzes. If I have secant squared minus 1, I always forget my arguments. If I have that, does that equal secant of t minus 1?
No.
Why not? Well, I get this a lot. Well, secant squared is secant of t like that, and I got under the square root, right? And then this minus 1, but can't that be written as 1 squared? Is that still 1?
Yes, yeah.
So I get a lot of people to cancel that with that, and then cancel that with that. Is that a legal thing to do?
I don't think so.
You don't think so? Can you give me an example of why that would not be legal?
What if it's like dot one is different number?
And you only have one square root.
Say again?
You only have one square root.
Okay, so the,
You can't just throw two around everywhere and square that. It would. It's legal.
try it. But I can. Give me a number.
9,
Well, give me the number that's not a perfect square.
7.
7. So, isn't 7? So you're saying if that wasn't a -1, let's say it was a 7.
Yeah.
Okay. Is this still 7?
Yeah, but why would we write it like that?
Huh?
Why would we write it like that?
Because now if I put it all underneath the square root, I can cancel those. That's the argument that I get a lot.
Aren't you gonna be left with square root of 7?
Yes. Okay, but my question, so 1's unique because the square root of 1 is kind of have that with roots has kind of an identity process, right, or a property that I get itself. But if it was like you said 9 earlier, if this was a 9, could I rewrite this as secant squared minus 3, or secant t minus 3? If it was 7, it'd be, so if this was so let's do the secant of t minus 4, secant squared of t minus 9. You would write secant of t minus 2, right? That's what I get a lot. I get secant t minus 3 a lot, right? So what is this number compared to that number? Square root. So if I get secant squared t of minus 7, a lot of people will write secant t minus root 7, square root. Okay, can you confirm or give me a way that convinces me that you can't do it instead of just saying you can't do it?
No, I can't. But I feel like you know.
Give me a number.
A bazillion.
Give me a perfect square.
9.
Okay, so 9. Because secant squared is a perfect square, right?
Yeah.
Okay, so give me 9 and put minus 1 there. We know that should give me radical 8, right?
Yeah.
Okay, which is 2 root 2. It's approximately probably 2.8-ish, something like that. I don't know. 9 would be 3 exactly, right? So that's pretty close. What we're trying to do here would be this. Radical 9 minus radical 1, isn't it? What's radical 9? 3. What's radical 1? 1. 3 minus 1 is 2. Are those two numbers the same?
No.
No. Okay. So when the radicand has a difference in it, you cannot separate it as a difference of radicals. We can do that with multiplication. If it was like 2x squared y squared, something like that, you guys know that you can go to x squared y squared, right?
Yeah.
The product or the radical or the square root of a product is equal to the product of the square roots. And that's because of the laws of exponents. But you cannot do that here, okay? So why I'm saying I get a lot of people to leave this numerator as secant minus 1 over secant. Does that make sense? Okay. How could I know, maybe calculator-wise, if I could do that? Can I type in square root of secant squared t minus 1 and then secant t minus 1, and when it asks me to put t in, and here it's just putting t as a value of 1, are those ever equal?
No.
No. So that tells me that algebra that I did go from here to here was not allowed. Does that make sense? Okay. I think that's a tool that you guys can use on your tests and quizzes. If you forget an algebra rule, write what you start with, and then write down what you think you're going to get per your rule that you're unsure about, and see when you evaluate the same value whether you get the same result. If you do, then yeah, what you think you can do was a legit thing you can do. If not, don't do it. Is that okay?
Yeah.
All right.
26.
Let's talk about 26 tomorrow.
Oh.
All right. I'd like to get into this a little bit. Hopefully you watched the entirety of that video I gave you yesterday. First part was unit circle stuff, right?
Yep.
Okay, but you get to the, 2/3 of the way through, at the end of it, starts talking about these graphs. And I do think it is beneficial for us to discuss these again, even though I asked you to watch it in the video. This stuff becomes critical, very critical for the rest of the course, okay? And I think it'll make those of you that are in physics, it'll make your physics a little bit easier when you start talking about waves, yes. So, we're on graph sine of t. So, remember when I'm graphing this stuff, and the video yesterday should have explained this a little bit, but the ordered pairs that exist on the sine function here, the x coordinate is going to be some theta or some t value, okay? And the y coordinate is going to actually be the y coordinate from the unit circle that we're going to couple with the theta, okay? So the idea, and I'll demonstrate this a little bit on this one here. Okay, so these two things, so the left-hand side is just the unit circle. So these are really the way we want to kind of view this is like these are two complete separate graphs. Does it kind of make sense? Okay, and we're going to take this circle and we're going to translate it into a wave. Okay, and the way we do that is that the first thing we're going to do is we're going to look at an angle of 0 degrees or 0 radians. Okay, and if I look at an angle of 0 radians or 0 degrees, it's going to put me right there at that point on the unit circle, correct? I'm going to get rid of this line, but I want you guys to remember that these two things are separate. Okay, when we do that, what is the y value of that red or pink, whatever color that is, point? 0, okay? So we got 0 degrees, and this ordered pair is 1, 0, right? So when I plot this as a wave, that is going to be my x value over here on this second graph, and that 0 is going to be my y value. So I plot 0, 0. Does that make sense? Okay. Another angle that we're comfortable with is 30 degrees. So if I go 30 degrees, it's a pretty good guess where 30 was. If we go 30 degrees, what is the coordinate for 30 degrees?
Square root of 3 over 2 and 1/2.
Okay. So then when I plot a point over here as a wave, the x value is that number. It's my angle. It's the theta. And the y value is the 1/2. So you're seeing right there at that point, I need to go over 30 degrees and then up 0.5. Now the question is, well, how do I go over 30 degrees on the x-axis? That doesn't really make a whole lot of sense. I'm actually moving over or pi over 6 radians. Okay, so we'll talk about that here in a little bit. This was just easier to program using degrees. The next one would be 45 degrees. If I go 45 degrees, get some things cleaned up here. 45 degrees, that distance that I'm going to go on the x-axis would be the 45 degrees, that's the theta. And then the y value would be the y of that ordered pair, right? Which is this radical 2 or 2. So we're going to do that process all the way around the unit circle. When I get to 90 degrees, the y value is 1, right? I keep doing that, and some symmetry exists. Would you guys agree that the y values in the first quadrant are the same as the y values in the second quadrant. Except for as I'm going in the first quadrant, we're increasing to those y values, right? When I get in the second quadrant, we're now going from a y value of 1, decreasing down to a y value of 0. So that's why we get a decrease in our curve. Would you guys agree that the third and fourth quadrant are the same y values, but they're negative? They're reflected across the x-axis. So this thing here creates our total sine curve, okay? As you work through here, you guys see that red distance? You see it being transferred from here to there, right? Okay, so wherever you see that red distance there, it's this sine or y value over here, and then the x was the angle of 288 that was paired with that 0.951, okay? There are some really nice ordered pairs here that exist for the sine. Those ordered pairs would be that one there, that one there, and that one there. Would those be really nice ordered pairs?
Yes.
Would that one likewise be nice?
Yeah.
And that one is nice, right?
Yes.
You guys remember with x squared, we remember like 0, 0, 1, 1, 2, 4, 3, 9. Those are the parent function points. Those are our parent function points for our sine function. Okay, those are the ones that we're going to want to commit to memory. So I want to show you a quick way of how we graph the sine from memory. First thing you're going to do is you're going to dictate where 2 pi is. So I'm going to come out here on my graph and I'm going to put 2 pi. Okay. On tests or quizzes, I will do that for you. Because on tests and quizzes, I'm going to grade like 35 of these things quickly. So that every one of you guys graph the sine t. It's 35 people doing this question. I don't want to graph 35 separate, different looking graphs, right? Because your 2 pi might be here, Blaze's might be here, Cole's might be here, Nick's might be here. Does that kind of make sense? So everybody's graph would be either condensed or stretched out. So I will dictate where 2 pi is. You usually then have to figure out everything else. So if that's where 2 pi is, this would be where 0 is, right? What would you think that mark right there would be? Pi? What do you think this mark right here would be? Pi over 2. Okay? Now we're missing a mark here. That one there. A couple different ways of figuring it out. But so really what I did here is I started with a total, right? I'm going to stop at that blue line. Cut that in half. I get there, right? And now I'm going to go from 0 to pi, cut that in half, right? When I cut that last one in half, this is kind of, it's not a unit, because it's not 1, but that is really my primary distance that I'm going to use to come up with all my intervals. So what I mean by that is if I take that distance and repeat it right there, I'm going to get my next mark on my graph. Does that make sense?
Yeah.
Repeat it right there, repeat it right there, and I can keep cutting and pasting that as far as I need to per the question, okay, for how far they asked me to go. But if that's pi, would you guys agree at that length is pi over 2?
Yeah.
Okay, so when I put it here, that's pi over 2, right?
Yeah.
So far I've gone 2 pi over 2s, right?
Yeah.
How far would that have been? 3 pi over 2s. So that is 3 pi over 2, okay? I get some people to mess that up. It is also the midpoint between pi and 2 pi, right? You guys remember how to find midpoints between endpoints on a coordinate plane? If I gave you like 7 and 15, what's the midpoint of 7 to 15? 7 plus 15 divided by 2. So if this is pi and 2 pi, add those together, divide by 2. Does it give you 3 pi over 2? Okay, so that's, I think, maybe the quickest way to do it. But going back to the parent function, so sine function at 0 radians, which would be right here, we're asking what is the y value as 0 radians. What is the y value of that coordinate or that point where my cursor is? And it'd be 0, right?
Yep.
So 0, 0. I'm going to plot that point 0, 0. Okay? Now, if I'm at 2 pi, so I always go from this, I find my first point, and I find my last point. Because my first point and my last point, if I look at this picture over here, unit circle, are they different? Is that point right there? I know it's hard to see. Is that yellow point right there? Is that yellow point right there any different than that yellow point?
No.
No. So if I had a y value of 0 at 0 radians, it's going to have a y value of 0 at 2 pi, right? Okay. Halfway in between, at pi, so at pi would be right there. What's the y value of that yellow point at pi? 0. So at pi, we're at a y value of 0 again. So I put those 3 points in. Okay. Now my y-axis, because this is all happening inside the unit circle. Okay. My y-axis will always go between 1 and -1. Okay. When you're going around the unit circle, and we're moving from 0 to pi over 2, your y values in the first quadrant are what kind of numbers? Positive or negative? Positive. So it's going to tell me when I travel from this point to get eventually to this next point, I'm going to have to go up. Okay? At pi over 2, what is the y value right there at pi over 2?
1.
1. So that's the next parent function point that I plot. Pi over 2 comma 1. Symmetry tells me at 3 pi over 2, what is that y value?
-1.
-1. Plot those 5 points. Okay? The red ones, that's my start, that's my end, halfway in between, we're at 0. Then halfway in between the first 2 red ones, we're at 1. Halfway in between the second 2 red ones, we're at -1. Then you connect, this is pivotal, with a smooth curve. Okay? I do not want to see on your quiz that I give you later this week, I do not want to see these things connected with those red lines, because that is not a continuous function, okay, per what we know in calculus. Okay, we want that smooth curve. Okay, now this distance here, this distance that this thing completes one cycle. Okay, because after 2 pi, would you agree that this thing's kind of going up into that half plane again, above the y-axis, and that's the same pattern as that, right?
Yeah.
Okay, so once it starts repeating itself, you have to determine what we call a period. This is the period for the sine function. Period of the sine function is 2 pi. Okay. When you guys talk about in a physics class, we don't talk too much about it in here, and it depends on the time that we have when we get to the end of this chapter, whether we talk about harmonic motion or not. It's not something that Rhodes asks us to talk about, but sometimes I put it in, sometimes I don't. If this thing were to do more oscillations between 0 and 2 pi, right now it's doing one oscillation, okay? What we call frequency is how many times this thing repeats itself inside a period. Does that make sense? So right now, or it's inside some interval. Right now, the frequency would be 1, okay? But we can change that, and you start talking about, okay, well, what if it does, something like this inside that period of 2 pi? We'd have to count how many times it repeats itself, divided by 2 pi, that gives you my frequency. Does that make sense? Okay, so those are the things we'll be talking about in a physics class. So period equals 2 pi. Let's do cosine real quick. So cosine starts at 0 again, go to 2 pi, cut halfway in between, gets pi, cut halfway in between, gets pi over 2. Gives me 3 pi over 2. Those are the starting points. Those are the same as the sine, right? Okay. Now cosine is our theta comma x coordinate from the unit circle. So at 0 radians, what is the x value at 0 radians on the unit circle? It is 1. So if I gave you that right there, if we're doing the cosine 0 radians, what would be the x coordinate of that ordered pair? It'd be 1. So I'm going to plot 0 radians, y value of 1. Okay? Unit circle is going to complete 1 cycle, right? And when I get to 2 pi, that should be coterminal with 0 radians, right? So I should have the same exact point. That's my start, that's my end. Okay? Now, at pi, what is the x value at pi for the unit circle? If you're right there on the unit circle, what is that coordinate? Negative 1, 0, right? So the x value is negative 1, right? So I'm going to plot the point pi, comma, negative 1. Be right there. So those are the initial 3 points that we're going to graph for the cosine. Does that make sense? On the sine, they were all on the x-axis, right? Cosine, they're like this. Okay? Now, that first point was a positive y value, right? This is positive. This one here is negative, right? The intermediate value theorem from college algebra said if you're traveling from a positive number to a negative number, what do you undoubtedly have to pass through? The x-axis. You have to pass through 0. And that happens for the cosine at pi over 2, halfway in between. Then if I'm going from a negative to a positive over here, from pi to 2 pi, again, I have to pass through 0, and it happens halfway in between. So now my cosine function, smooth curve again, is going to look like that. Okay? If I make that smooth curve, then all those other like 30 degrees or pi over 6 comma radical 3 over 2 is going to come up where it needs to be, right? So pi over 6 is going to be, maybe like right here, okay? Tomorrow, we're going to talk about being able to move these things, okay? Because they're just functions, right? So we should be able to move them up, down, left, right, stretch them, reflect them, that kind of stuff. We're going to do tangent. Oh, absolutely. Tangent, cotangent, secant, cosecant. Those are on the agenda for later this week and early next week.
Is there a quiz on Friday?
Oh, probably.